This is a heat engine. Every power plant, every car engine is one. A gas trapped under a piston, between something hot and something cold. Watch. Heat pours in from the hot side, call it QH, in orange. The gas swells and shoves the piston out. That push is work, W, in green, the whole point of the machine. But here's the catch. To go again, it's forced to dump heat into the cold side, QC, in blue. You pay QH, you get W, and you're made to throw QC away. So the question that built the industrial age is simply this: how much of the heat you pay for can you actually turn into work? Could you ever get all of it and dump nothing? Hold that thought. Last time, the second law, the universe keeps a ledger, and heat won't climb uphill for free. Today that ledger hands us one exact number. Let's draw the same engine honestly: pressure up the side, volume along the bottom. One trip round this loop is one cycle, and the little piston up here moves in lockstep with the point. Stroke 1, touching the hot reservoir, the gas expands at fixed temperature TH, the piston slides out along the top curve, from A to B. Stroke 2, now insulated, no heat in or out, it keeps expanding and cools, from B down to C. Stroke 3, against the cold reservoir it's squeezed back at fixed temperature TC, from C to D, dumping heat. Stroke 4, insulated again, squeezed the rest of the way home, back to A. For strokes, 2 at constant temperature, 2 with no heat at all. And the area trapped inside the loop is exactly the net work W. Only the flat legs carry heat. On a constant temperature leg the internal energy doesn't change, so by the first law all the heat comes back out as work, and the area under a 1/V curve is a logarithm. So the hot leg heat is mRTH times the log of the volume ratio. Same on the cold leg, but the gas is squeezed, so the heat is negative, it leaves. QC is minus mRTC times the log of its volume ratio. The two slanted legs are adiabatic, no heat, and obey T times V to the gamma minus 1 is constant. Gamma is just a fixed number for the gas, from the perfect gas chapter. Write that for each slanted leg. Now divide the first by the second. The two THS cancel, the two TCS cancel, the powers cancel, and out drops a clean fact: the two volume ratios are exactly equal. Now the ratio of the two heats, using the amount dumped, the size of QC, a positive number, heat you dump over heat you pay. The volume ratios are equal, so the two logs are the same number, strike them out. The MR cancels too. All that survives is temperature over temperature. Now efficiency, one honest line at a time. What you get over what you pay, work over QH. Over a loop the work is heat in minus the amount you dump. Split the fraction, 1 minus the dumped fraction. And that fraction is TC over TH. So it collapses to 1 minus TC over TH. First, why Kelvin, never Celsius? In Celsius the cold temperature can be 0 or negative, then TC over TH blows up or flips sign, pure nonsense. Kelvin starts at true 0, so the ratio is always a clean number between 0 and 1. A furnace at 1300 Kelvin, rejecting to a 300 Kelvin day. The ratio is 300 over 1300, the ceiling is 1 minus that. 76.9%. Of all the orange heat you pay for, that much turns green, into work, and the rest, 23%, stays blue, dumped into the cold, by law. Trap 1, don't flip the fraction. It's cold over hot, smaller over larger. Flip it and you get the old slide 78%, a number that doesn't even come from our formula. Cold over hot, 76.9. Trap 2, dreaming of 100%, all heat to work, dumping nothing. Here's why you can't. To start the next cycle you must squeeze the gas back down while it's cold, strokes 3 and 4 of the loop you watched, and cooling it hands heat to the cold reservoir. You're always forced to reject QC. That's the Kelvin-Planck law. 100% engine isn't hard to build, it's illegal. One last thing, why is this reversible engine the best? If anything could beat it, you'd run this one backwards and pump heat from cold to hot for free, the forbidden thing again. So Carnot sets the ceiling for every engine ever built. Next, the same bookkeeping shapes the isentropic relations, how this clean logic governs the way real gases flow.